Hey, Matt 30-2, and welcome to 5.2. It's going to be just characteristics of equations of polynomial functions. So pretty much like the way it looks. So if you graph it, is it going to look something like that? Is it going to look something like that? Or, like how do we know? How do we just know that by just looking at something like this? So I think the best way to do this is kind of jump straight into it. So given the equation f of x, really you can think of that as like just y too. You've seen that a lot of times, right? Just, y. Why it's written like f of x, remember, just means that if I put any number in place of there, let's say I put a 1 in place of there, then that would just mean that all of these become 1s as well. And then you'd have 1 squared minus 13 times 1 plus 40. If it was a 2, same thing, 2 squared, yada, yada, yada. So that's just a different way of writing that other than y, right? All right, so given this equation, describe the graph without graphing on your calculator. Can you find the y-intercept? So the y-intercept here, so I'm just going to sketch something out kind of quick here. So if I just made a little grid like this, the y-intercept, remember, is going to be where it crosses, like it'd be like that, right? Like where it crosses here, and this would be the y-intercept if that's what it was, right? I'm not saying that is the graph, but that's what we'd be looking for. So what is the value of x? So remember, x is like this way, right? Back and forth like that. That's the x-axis, and that's the y-axis. Oh. What's the value of x when we're looking at the y-intercept? Well, it's going to be 0, right? That's, this would be 1. That'd be -1. So like x is equal to 0 at that point. So if I want to figure out what the y-intercept is, all you have to do is put 0 into place of x for all those things. So if we did that, I'm just going to erase this for a minute. Well, then you've got 0 squared minus 13 times 0 plus 40. So you can see that like that would just be 0 and 13, like that term would just be 0. And you'd just be left with 40. So that's going to be a common thing with these, is that when you're looking for the y-intercept, if it's in standard form like this, it's going to be really easy because it's just going to be the last number. It's going to be the constant term 40. So I can just tell right away that the y-intercept for this is going to be at, well, if we were writing it out, it'd be when x is 0, y is 40. So that'd be the y-intercept. Okay, find the x-intercepts. This one we got to do a little bit more work. All right, so now if I had my little grid there, right, and I want to know what the, let's say I had something like that, and I want to know what the x-intercepts were. Well, now y is going to be equal to 0. It's the flip, right? So when y is equal to 0, we're saying what is x equal to? And that's a little bit tougher. We can write it out. So let's say instead of f of x or y, it's just like the same thing, right? Let's just write down 0 is equal to x squared minus 13x plus 40. And so the reason why that's 0 is because y is equal to 0, right? So now if I solve for x, I should get 2 answers I would expect here because it's a quadratic equation that has a leading coefficient or leading power of 2. But how do you solve for x? Well, we need to factor it. So you're going to say 0 is equal to, give me an x and an x. And I'm asking myself, okay, what multiplies to 40, adds to 13? What about 8 and 5? And then make sure I get my signs right. They either have to be both positive or both negative to multiply to a positive number. They got to be both negative to get to add to negative 13. Okay, so then looking at this, I'd say, well, what would x have to be to make that term 0? Well, x would have to be equal to just positive 5. And on this one, x would have to be equal to positive 8. So those are my 2 answers right there. So positive 5 and positive 8. Another way of writing that in point form there, like we did above, would just be so 5, 0 and 8, 0. All right. Knowing that the vertex always falls halfway between the x-intercepts and or between the x-intercepts, find the x value of the vertex. So what it means by that is, so far we know that we've got a graph. So let's kind of just put down points for everything we know so far. So the y-intercept is going to be at like 40, so a big number up here. Our intercepts are going to be at 5 and 8, so something like that. So you can kind of see, I can even tell right now that this is going to do something like that, right? It might be like quite a bit lower than I think down there, but that's the general shape. What it's saying is that the vertex, remember this is the vertex, like the point right on the end there, like right there, that's the vertex. The x value of that is going to be just right halfway between that, so it's going to be between 5 and 8. Okay, so you might be able to do this one in your head to figure out what halfway between 5, so right there, that's the x value of 5, and that's the x value of 8. So we need right in the middle, right? Because that's what the vertex is. This one I'm drawing right now is called the line of symmetry, and it goes right through the vertex. So we want to know what is that value right there. So if you're not sure about that, just go 5 plus 8 and then divide it by 2. You're really finding the average between those two numbers, right? If you add two numbers, you got two numbers, and you add them together and then divide by however many numbers there are, that's giving you the average. So we're just going to go 5 plus 8 divided by 2. So 6.5. Okay, so that's the x value. That's what our line of symmetry would be, and that's what, if we were going to figure out what this point is right here, that'd be the first number, 6.5. It's going to be 6.5, comma, and then whatever the y value is. We don't know that yet. But now we're looking for that. So let's do a different color. So now we're looking for that y value, right? What is that? Well, as long as you know any point on, like, from a function like this, you can find the y value. If I know what the x is here, I just got to plug it in, and then it's going to pop out a y value at me. So if I want to know the y, let's just go y is equal to, what was it, x squared minus 13x plus 40, right? And then just replace all the x's with 6.5s minus 13 times, that's supposed to be a 3, 6.5 plus 40. And just so you're clear, this is something that people kind of forget or don't really realize too, is that I put x back into this, right? I put 6.5 back into the original formula. Well, I guess before it said 0 on the one side. But it would have also worked after it was factored, right? That's the exact same expression. So I could have done this exact same thing with the factored version and still would have got the right answer. It might have been actually even a bit easier to do the calculations too, but okay. Anyway, so if you put that in your calculator, you get y is equal to negative 2.2, which makes sense, right? Like, I'd expect it to be below the x-axis here because, this is kind of what we thought it would be. Whoop, let's go back there. Yeah, okay. So I now know that the vertex point here would be 2.2 is what would go in there, right? Okay. How can you tell if it opens up or down? Well, I could tell earlier than this because it had a y-intercept there. It had two x-intercepts. And I knew that we were dealing with a parabola because we're dealing with the quadratic equation, or quadratic formula. So that's one way. I also know that it opens up because it's a positive number out front. So our original equation was y is equal to x squared minus 13x plus 40. Look for the number out front, or the sign out front, I should say. If it's a positive, that means it's happy. So positive means it's like happy, right? You're positive, so it opens up, right? That's why this one looks like a happy face. If you drew like, eyes there, it's smiling, right? If there was a negative symbol out front of that, it would be so if this was like negative x squared, then it would be opening down, which looks like a frowny face, is negative, right? So positive opens up, negative opens down. That's kind of an easy way with the happy face, sad face thing to remember that one. Okay, describe the end behavior. So to describe the end behavior, we have to just make sure that we've got our quadrant system figured out. So, didn't have it right. One sec. So if I go like this, we got to make sure that you know that this is quadrant 1, this is quadrant 2, 3, and then 4, right? So it starts in this one, goes and then goes counterclockwise, right? Like a little bit different than you might think. So anyway, describe the end behavior. Well, you'd say that it starts in quadrant 2 and ends in quadrant 1. So that's pretty much it. So quadrant 2 to quadrant 1. Yeah. Now briefly sketch the graph. So that's pretty much, we've already done that up here. So if you've already done that, then I don't know, maybe put a check mark by it or something. Okay, so now, based on the graphs in the left column, answer the bullets in the right-hand column. Some bullets will have more than one answer. All right, so just in general, we want to get some rules for functions of degree 2. And by degree 2, I mean what we were dealing with up here, right? Degree was like the highest power of the leading coefficient, or the leading term, I should say. So number of x-intercepts for this. Well, this is generally what they're going to look like, right? Every one of these ones with a leading coefficient of 2x squared plus, like 4x minus 10, something like that, right? They're all going to look something like this. If you put a negative in front of it, it would look like this, right? It'd be flipped upside down, and then just they could be moved around anywhere in between like that. So that's the general idea. So number of x-intercepts. Well, this one has 2, right? But it's also the possibility that it doesn't have any. It could be down below, so not touching at all. But then it could also be the case that you have one that, let's say, comes up, just touches, and then goes back down again, so right there. So number of x-intercepts, it could be 0, 1, or 2, and that's it. And just as a little reminder, maybe you remember this from 20-1, the quadratic equation. Maybe you remember this. We said this was called our discriminant value, b squared minus 4ac. Remember that if this was all equal to 0, then that was going to just be, you only get one answer out of this thing, and that would be this situation where it touches once, right? If you got a negative number underneath there, then that's where you don't have any, like your x-intercepts wouldn't exist at all. So that would be this situation where there's none. And then every other time, like if you've got like any kind of positive number down here, then you would end up with 2 different answers because of the plus and minus part of this. And that's why we would get this. So just a little heads up, to remind you of kind of what we were doing last year there too. Yeah, hopefully that made sense. Okay. Number of y-intercepts. Well, you're only ever going to have one y-intercept, right? That's kind of a property of these things, is that you're never going to have anything else. Like you'll always have one intercept, or y-intercept, so 1. Number of turning points. When there's degree 2, there's only ever going to be one turning point. And by turning point, I mean like this one was going down this way, right? And now it turned and went back upward. So that's we call like the vertex there a turning point. Okay, end behavior. Well, it's always going to go either from quadrant 2, so quadrant 2 to 1, or it's going to go from 3 to 4. Right? It's either going to be opening up or it's going to be opening down, is really what it's saying. So now domain, remember what domain means. Domain means like what is y allowed to equal. Well, y in this case, or sorry, not y, domain's going to be what is x allowed to equal. So x in this case is the easy one, right? So if you took these functions that we're dealing with, let's say, we got this, and we got a function that opens up like, this, y goes on forever left and right. It's going to go forever that way, and it's going to go forever that way. So what we would say then is that x is a member, all we would say is that the domain here, so sometimes you just write like d and like dot dot just to make it short. You'd say domain is where x is the member of the reals. And what we mean by that is that, x is any number, any real number going that way or that way. Okay, The range is always going to be, so it's always going to be either greater than or less than whatever the vertex is. So what I mean by that, if we've got a vertex, this is a new thing I figured out in here, so I'm using it a lot. Okay, so if we got a vertex, something like this, right, where we figured out the vertex by first, figuring out what the, difference between those was. We did that in the one above. That's not straight at all, but pretend it is. Anyway, so we got a vertex there where we got some x value. Let's say in this case it was 2, and we got some y value of like 4 there. What we're always going to do for the range is, well, that's the max, right? That's the top of where this function is ever going to go. 4 is the top. That's it. It's never going to go any higher than that. It's only ever going to be lower than that. So the range is what you say, y can be equal to. So the range is always going to be y is, well, in this case, less than or equal to 4. And then you'll quite often see, like comma. So the comma means where y is a member of the reals. So this just means it can be, as long as it's below 4, it can be anything. That's kind of what that last little tagged on thing at the end there means. But this is kind of the big one. You got to figure out the vertex. So range, it's the y value of the vertex. So if you want to write that down too. So y value of vertex is what's important there. All right, moving on. So degree 3. So degree 3 ones are ones that are going to do like a squiggly like this. It's going to go up and down and whatever, right? So number of x-intercepts, if you think about it, well, this one only has 1. Is there a way you could ever have 0? No, there won't, because it doesn't like turn and then go back up from where it came from, right? So there's no way it can miss it. It's going to have to hit the x-intercept or the x-axis. So it's got at least 1. It could have just 2. If, let's say, we're looking at this one, it went up, came down, and then touched, and then went back up again, that would count as 2 x-intercepts, right? There'd be just the 2 there. So it could be 1, 2. And then it could also have 3, because it could be like this one, right? Where it crosses there, there, and there. So 1, 2, or 3 x-intercepts. So number of y-intercepts. Again, there's only one way that can happen. There's only ever going to be one y-intercept, right? It can't do more than that. Okay, number of turning points, 2. There's going to be 2 times that it turns. It's going to go, in this one it's going that way, and then it turns, and it's going that way, and then it turns, and then it goes that way, and that happens twice, right? 1, 2 times. M behavior, it's always going to go diagonal, right? So it's either going to go that way or that way. So M behavior, it's going to go from 3 to 1, or it's going to go from 2 to 4. That was terrible, but anyway, you get the idea. All right, domain. So domain, again, domain's really easy with these ones, because no matter what happens, this is going forever that way, and it's going forever that way. So we just say domain, so D and dot dot, an easier way of writing it. You just say X is a member of the reals. Your range, well, in this one, it's actually quite a lot easier, because this is also just going from forever that way to forever that way. So along the y-axis, y is also just going to be, range, R, is going to be y is a member of the reals. So a bit easier for that one. Okay. Ooh, but just one more thing that I'm probably going to just want to tell you on here is, how do you know the M behavior, whether it's going to do that or that? So in the last one, we said that you could figure it out from whether it was positive or negative. So if it was, so we're dealing with degree 2 here. Sorry if I'm kind of jumping around too much. 2 to 1, that would be if it was positive, right? If there was a positive number out front of it. So if we had, some kind of, function, and it was positive up front, it'd be opening up. If it was negative, then it would be opening down. It would go from 3 to 4. So how do we figure out this guy over here? Well, if the number is positive out front, that's this one. And I don't know, one way to think about that, if you're okay with thinking about slope, you know, if you had a graph that was going up like this, that would be a positive slope. You can say that, you know, rise over run is positive, right? So, and that's just kind of the way I think you would normally think about positive as being, is like starting from the left and going up to the right. So that's a positive number out front. So this would be, you know, positive out front. And then negative over here, it's going down. So the slope's going down. So I guess you can kind of think about that as you're like, you know, it's a negative thing to be going down, right? It's better to be going up. So that's negative over there. So in that case, if we were going from 3 to 1, you're going up. So that would be positive. This one over here, from 2 to 4, that's like sliding down the hill. So that's going to be negative coefficient out front. So why I bring that up is because right off the bat here, I'm looking at G, and it's got a degree 3, so it's going to be one of those squiggly guys, right? And it's a negative out front, so I know it's going to be going something like that, right? It's going down, but not like that. It's going to be, you know, some kind of squiggly thing going down. Okay, so let's see if we can find a squiggly thing going down like that. So there's only one of them. I don't even need any more info, right? That's the only one. So G, that has to be with this one. So I'm not going to actually circle these. I'm going to let you guys do it when we're done here, but I'm just going to give you kind of a hand. So J, let's move on to. So it's going to be, so it's squared term, right? And it's a positive out front. So I'm looking for something that does this first, right? It's positive. It's like a happy face. So I'm looking for that. And so let's see if we got any. So we got that one. So that's a contender. I've got that one. That's a contender. So I need to kind of split it up a little bit. The other bit of info I have here is that the last number is -2. Well, that's my y-intercept, right? Because if that was 0 and that was 0, I'd be left with -2. So that doesn't have a y-intercept of -2, but that one does. So, oops, but that one does. So that's the one you're looking for. Okay, for this one, we've got a leading coefficient that's positive, and it's got a 3 for my degrees, so it's going to be one of those squiggly guys, and it's going up. So that's this one. That's the only one you can do. Okay, this one, since it's only just one out front, don't worry too much about the fraction. It's going to be a straight line. So we've dealt with these before, right? The negative that's going on there means it's going to be going, you know, down. So it's like this one, or perhaps like this one. So we're kind of narrowing it down here, right? That's pretty much it between those two. And then the last thing I'd be looking at is the number, the trailing number, right? Because if that was 0, you'd be left with -3. So which of these two has -3? Well, oh crap, they both do. That one and that one. Okay, so we need to do a little bit more work to figure this one out. So a couple ways of figuring this one out. You could look at this number right here, right? The number out front. This is the slope, right? That's the, you know, in the formula y is equal to mx plus b. M is the slope. That's how much it's like changing. So it says -1/2. That means it's going to go down 1 for every time it goes over 2. Rise over run, right? This is your rise, this is your run. Well, if I'm looking over here, I can see that this one does. It goes, if I'm kind of starting here, it goes down 1 and then over 2. So it's got to be this one. But if you were unsure about that, the other thing you could do is solve for the X intercept. And the way we could do that is go, okay, 0, because, you know, y's needs to be equal to 0. And then -1/2 or x/2, I'll write it as same thing, right? Is equal, or -3, I mean. And then what I'm going to do is go, okay, I'll add 3 to both sides, so +3. So I got 3 is equal to -x/2, and then 2 times, multiply 2 on both sides. So now I've got 6 is equal to -x. I'll divide both sides by -1. So -1. So I end up with, kind of running out of room here, but I end up with x is equal to -6. And it is equal to -6 in this one. So you could also do that. Okay, I'm going to let you guys do the rest of them there to match them up. But yeah, that's the general idea of those. I am actually going to let you guys finish these ones too, because I think you're all right. Q2, that means quadrant 2. So if you need to write it down, remember 2, 1, this was 3, and this is 4. Okay, so just possible just means like sketch it out. What would it look like? You don't need the whole thing like y is equal to x squared plus yada yada yada. Just sketch out a possible graph that would look like. Okay, let's make sure that everything else you know. This you might look at and be like, huh? I'll just help you kind of read through this. This is a range, right? So it's telling you what y is allowed to be. And it's saying y, and this little dash, if you're saying it out loud, it says y where y is greater than or equal to 2. That's what that meant. Or negative 2. And then, yeah, I guess where again. Y is a member of the reals. So that's kind of what that whole thing. So it's just kind of telling you the restrictions on y. So that this is really talking about the range. The most important bit about that, though, you can almost kind of ignore all of it other than this, right? That's the one that matters to us. That is where your vertex is, right? So if you're wondering where your vertex is, I know at negative 2 and then something, right? Let's say it's there. That's my vertex or something. I know that the y value, I don't know the x value yet, but I know the y value is going to be negative 2 because the y has got to be greater than that. So I also know it's going to be opening up, right? Because it can't be opened down. If it was opening down, it would be anything less than that. So it's got to be opening up. And then, yeah, there's your hint. Oh, sorry. And then this is just another point that it passes through. So it passes through x is equal to 0 and y is equal to 4. All right. Okay, so C, range, and domain are both members of the reals. So that just means anything, right? There's no vertex. There's no turning, or yeah, sorry, there's no vertex in this. And they have turning points in quadrant 3 and 1. So just turning points means, something like that, right? That'd be a turning point, and that'd be a turning point. All right. D, entering quadrant 3 and leaving quadrant 1, and has turning points in 2 and 1. So see if you can answer that one. Okay, and that's it. So that's it for that video. See you guys in the next one.